before starting this factor analysis, let's start from the very beginning, from where it belongs, right? So it is basically a part of machine learning, okay, where you have not started the machine learning technique on the data set yet, but before that you decided or you feel that there is something in the data and you have to deal with the data. So on that place, this factor analysis come into play, and it is one type of descriptive analytic task. So what is this descriptive analytic task? If I explain, then it is basically tells you or describes you something. Something means here the data. Okay, so a descriptive analysis task basically describe the data in different ways. Also, it try to find out patterns or trends in the data, right? So factor analysis also actually based on this kind of finding on the or based on the pattern present on the data. We use those patterns, those trends in a mathematical way present in the data set to represent the data in a new form so that it can help the further analysis of the data. So if we talk about descriptive analysis, then if you look at this whole picture, where descriptive analysis is basically a part of exploratory analysis, where people try to explore new things, or sometimes it try to explain the data. And factor analysis performs all these things together. Sometimes it helps you to explore the data, sometimes it helps you to confirm your findings, sometimes it helps to describe the data. Okay, so overall factor analysis plays a major role in the latter part of the data analysis or at the beginning of the data analysis. So it is basically everywhere. And if we talk about the descriptive analysis techniques, then you can see that principal component analysis, correlation analysis, cluster analysis, all are the techniques which we can use as a descriptive analysis technique along with factor analysis. Okay, and factor analysis is an unsupervised learning, and there is a very small differences are exist between principal component analysis and factor analysis. We will see all those differences in a broader way later on in my slide. Okay, so factor analysis, basically after applying this factor analysis, we can do some descriptive analysis of the data. We can also explore the data, and we can also confirm the data, as I said earlier. So before starting factor analysis, first understand what is factor, right? So hopefully you have, all of you have seen this equation, right? Something A multiplied by B equal to C, right? So here A and B are two factors, and by using these two factors we get another output that is called result here as a product of A and B, and we can say that 6 is a factor of 2 and 3, right? So a number or quantity that when multiplied with another, that means here A and another is B, produces a given number, that is here it gives you a sequence expression in the form. Okay, so a circumstance or fact that contributes to a result. So these are the circumstances which produces the result, this 6. So here in case of factor analysis, we have such kind of like A or 2 here we already have. We have to derive this another factor, and then we will get the product or the result which we will use later on for the clustering or classification or any other data analytics for data analysis task. Okay, so we will come to this equation at the end of the session. Okay, again, now we in our life we have several factors, right? Like economical factors, social factor, environmental factors, and biological factors, psychological factors. There are many factors are available surrounding us, surrounding to our uh, different aspect, right? So, like, and among these factors, some factors you can measure by some unit, and some factors which are not measurable, right? Like basically the psychological factors, um, like family relationship, that cannot be measured, but you can measure it based on some factors, say based on some other factors, right? Similarly, some economical factors like a person is very poor. Poor signifies this poor or rich, or this kind of factor depends on many other factor, and then we say that this person is very poor, right? So here we will start from the factors which are measurable, and then at the end we will try to derive some factors which are not measurable from the factors which are measurable. Okay, so when we measure something, or by using for this kind of factors, what we get the data. That's actually the data. Here factors are the variables or the column names, or the columns in a usual representation of the data set, and of attributes, you can say, and the objects are represented by the row, right? So hopefully you can understand that what these factors are. And when we collect the data, measurable data, or measurable or the measurements of those factors, then we get the data, and then we come to the field of data science, and then we come to the field of factor analysis, right? So what is this factor analysis is? Factor analysis applies when you have too many factors, okay, or too many measurable attributes, but to do analysis on those too many attributes you feel difficulties. So what you have to do, you have to reduce the data set. So to reduce does not mean that delete some attribute. Deleting some attribute gives you loss of information, right? Information loss or the data loss, and that results to the inaccurate analysis. So without losing any attribute, how we can reduce the set of attributes based on the relationship presence on those measured attributes, that is called factor analysis. And this relationship may be present in different form, like correlationship, patterns, trends, in different ways, right? Like for example, a human can be measured by these many factors. There are many other factors like stature, weight, chest circumference, waist, all these things. There are many other factors are available to measure a human, right? Now, if I say that there is no dependent or independent variable among those variables, that should be a required property. That in this case, the variables or the factors at the beginning, what we have, the measurable factors should not be depends or independence along depends between each other or independent from others. Okay, there is a term, we call it interdependencies. Okay, we call there is a interdependencies between the variable, right? So when we try to use that interdependencies or the relationship present between the measured variables and prepare a condensed representation, right? Condensed representation means, say you have 100 columns and you want to represent it in 10 or 5 or 6 or 20 columns. That means a condensed representation of the data without deleting any previous 100 any one of the 100 attributes. So it is a condensed representation. we try to identify the pattern in the data set. Among those 100 attributes, what are the patterns there, and then we try to group those 100 variables, and we try to group based on their correlationship, where one group, the attributes in a group have highly correlated compared to the others, right? So for example, here these are the attributes what I have already shown you earlier, that different attributes of a human, and we can create factors among like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So what we can do, we can group these 18 attributes into three different attributes, right? Factor 1, factor 2, and factor 3. What kind of name you will give, that is different thing, right? But how many you can generate, that there are some mathematical formula, there are some mathematical tasks to do, and factor analysis actually aims to do this, right? So here what we have done, what is or actually done here in this case, that 18 attributes are grouped into three different factors. Like for example, factor 1 groups weight, chest circumference, waist circumference, hip circumference, thigh circumference, and vertical trunk circumference. Like these, many of these things grouped together and created a factor that is called circumference. There is another factor, that is 2. Factor 2 group some other attributes and you name them as length. You can name any other word, maybe meaningful, maybe meaningless, but better to give some meaningful word, right? So similarly, factor 3 groups some of those 18 attributes and create a ultimate 3 column data set instead of 18 column data set, right? So in factor analysis, within group variable must have a high correlation and between group have low correlation. Like you know that in case of clustering, you have seen, hopefully you have seen this word, that between the class within a cluster, the dots or the points have high correlation, and between the cluster have low similarities. And we have or actually we use similarity measure in case of clustering, and here we use correlationship between the variables. So basically these are nothing but a grouping the columns. So it is a technique that reduces many variables into fewer number of variables. That's why it is also known as dimensionally reduction techniques or data summarization, because 100 columns is summarized into 3 columns. So because of that, it is also called data summarization techniques. So the main fact in case of factor analysis is that we try to extract the common variance, common variance among the variables in the data set, and try to extract the maximum common variance and put them together in a common score and make a group, and that is actually known as communality, right? So for example, there is some attributes. Say for example, these are the attributes of a restaurant, measurable variables, where you can collect the data, like waiting time, if you go, and how much waiting time is there, the cleanliness of the restaurant, the staff behavior of the restaurant, taste of the food, food temperature, freshness of the food, like this. So you can measure these terms, right? By maybe between 1 to 100, or 1 to 5, or 1 to 10, you can measure these values, and from this you can derive that how clean the restaurant is, or what is the service of that restaurant is. By these three factors you can decide this. So when you give this another factor, cleanliness or service quality, then this service quality is actually derived from this observed variable. So this is the new variable, and these are the observed variable. This is the old variable where you have collected the data from the user. And the food quality is the new derived variable, which is actually derived from the other three of the variable which are observed variable. So by the values of these three variables, you create another attribute, that is food quality, service quality, or cleanliness, whatever it is. So this kind of variables which are not observed, which are actually derived from the observed variable, are called the hidden variable or latent variable. Okay, so these factors which are actually derived from the observed variables are called the hidden variables or latent variable. Okay, now, so these hidden variables or observed variables not directly observed, it is the value of these attributes are actually calculated from the value of these attributes. Okay, variable inferred from the observed variable fact. So, and this is a mathematical model where latent variables are actually generated. So that's why factor analysis is also called a latent variable model. Okay, and other example of this kind of latent variable can be quality of life. Like, to identify or to get a value of quality of life for something, you have to depend on many other observed variables data, and then you can decide that what is the quality of life, because quality of life depends on many other factors. Happiness is also depends on many other factors, right? Moral, confidence, conservativeness, all these actually can be considered as a hidden variable, and these variables can be depends on many other observed variables in real life. Like, for example, these are the personality traits: outgoing, curious, sociable, helpful, hardworking, aggressive. So among this set of personality traits, what we will do, we will create a data set. Okay, and then based on the data set, we will try to generate few latent variable, like, for example, conscientiousness, extraversion, agreeableness, openness. So these are the different personality types which are actually based on, which are actually depends on these personality traits. So if we have a data set of some set of human on this field, we can reduce the data by this term, by combining few of these term into this, and then create a new data set with fewer columns, right? This is basically or majorly used in the survey data set, or and also used in many other field also. Like, for example, you create a survey form to understand these facts, to understand these facts, that how much outgoing a person is, curious a person is, social a person is. Like this, you created several queries, several questionnaire, and based on that you collect the value from different from a set of entity. Okay, and then you create a data set like this. So we have many of these kind of personality traits. We are not making it much difficult. What we are doing, we are creating, or we are creating a data set of 6 columns and 20 rows. Okay, that means 20 rows corresponds to 20 different person who gave the feedback, and these are the value of their feedbacks: for outgoing, social, hardworking, dutiful, warm-hearted, helpful. So these are the value they have given in that survey form, right? Now, this data, these are all numeric, right? But we can have feedbacks like this way also. This way means the categorical format. Not only numbers, but categories can also be there. Binary values, more than two categories can also be there. So in those cases, our factor analysis not work, where you have categorical data, or a binary category, or more than two categories. So in that case, what we had to do is binary or Boolean factor analysis, which I will not explain here. Okay, so when you have categorical data or categorical attributes, in that case you can do factor analysis, but that is not the usual factor analysis. In that case, what you have to use, you have to do the Boolean factor analysis. But the general factor analysis term actually used for this kind of numeric data set. So to apply a factor analysis process on a data set, you should have some assumptions. What are the assumptions? That the data or the values of the data set must, there should not be any outlier or missing values in the data set. Values must be numeric type, as I have shown you. That means maybe interval scale or some other scale. Observed variable must have correlation or interrelation, that I have already mentioned, that it actually find out the correlationship between the variables. So there should be some correlationship, and to do that there is a Bartlett test is there to understand that whether there is a correlation present or not, right? So if there is no correlation and if you apply factor analysis, what will happen? Nothing but individual variables will be considered as an individual factor. So if you have 100 variable and there is no correlation, then that will generate 100 factors. So it is actually basically it will be an useless process, right? So variable must be homogeneous, and if you use heterogeneous kind of data in a variable, then it will give you wrong outcomes, or whatever the desired expected outcomes will not be achieved. Variable must be metric variable. A variable must be linear. Some form of multilinearity can also be possible, but the data should be normalized data. Multivariate or multivariable normality will not be considered here. So if the data is multilinear, multivariate, multivariable, then you can apply factor analysis, but there will be a problem in the result set. It will not be as expected by the factor analysis. Okay. Now, what will be the sample size in case of factor analysis? How long the data set should be? Like for example, I said there should be if there is 100 variables. I have not said what will be the number of rows. So if the variable is 100, minimum requirement is rows should be 500. That means 5 is to 1 should be there. 5 rows corresponding to one variable. So if you have 100 variables, 100 columns, there should be minimum 500 rows should be there in the data set. The better is 220 is to 1, that means 2000 data set in case of 100 variables, or 100 columns. If you have a data set with 100 columns and if you want to do factor analysis, better if you have 2000 rows. Okay, so in between there is a preferred choice is there, that is 10 is to 1 is a preferred choice for a good output, for a good outcomes. That means if you have 100 variables, 1000 rows are preferred. If you have more than that, it is very good. If you have less than that, that is also fine, unless and until it is not less than 5 is to 1. Now there are different factor analysis methods are available. Like as I have already mentioned, principal component analysis is a process. There are maximum likelihood estimation method, image factoring, weight square regression based method. There are many other method. If you look at the literature, there are many such methods are available. But what factor analysis actually means is by common factor analysis. Why the term common is used, I am explaining right now. Is that in case of principal component analysis, what happened? You choose among those 100 variables, you choose one of those variables to represent the others. But in case of factor analysis, you are not choosing the among them, you are creating another variable. Okay, and that is based on the common variance present in those variables. In case of principal component analysis, it uses the total variance in those variables. But in case of common factor analysis, it uses the common variance. What does it mean, the common variance? Common variance is actually, if you look at the total variance of a particular variable, it consists of three different terms. One is the common variance, another one is a specific variance, another one is the error variance. Okay, and in case of PCA, principal component analysis, we include all these three variants. But in case of factor analysis, common factor analysis, we use only common variance. So common terms come from this common variance. Okay, because we are considering only the common variance to do the factor analysis. That's why it's called the common variance, right? So let's look at the common factor analysis in detail. Common factor analysis consider the common variance and put them into factors. Factor means new variables. So find out the common variance, common patterns, common relationship, and put them into the factor. It does not include the unique variance or error variance at all. For example, let's this example I have already, this data set I have already explained to you what is this data set is. Now let's use this data set, okay, where you have 6 columns. Now how many factors you can create from here, like how you can summarize it, how much you can summarize it, how many factors you can create from these 6. Say you said, sir, it is better to create 3 variable instead of 6 or 2 variable instead of 6. So let's choose 3. But is there any reason behind this? What is the background equation behind choosing these 3? Why you have chosen 3? Because there are correlations. That means, sir, you can say that okay, outgoing and sociable can be a relatable things. There can be a correlation. Hardworking and dutiful can be a correlation. Warm-hearted and helpful can be a correlation. But how to find out that mathematically? If you have 100 variables, how you can find out that? And sometimes these columns does not have meaningful names. So how you can give meaningful names to them? So there, actually correlation matrix can help you. And this correlation matrix in case of factor analysis helps you in many different times during the factor analysis. So it helps you to decide the factor number of factors, and that can be done by using the eigenvalue calculation and also by using the Scree test or the knee test. Okay, what are these? In case of eigenvalue, you try to find out the eigenvalue of each variable and each factors. If you consider them as a factor, then if the eigenvalue for each of those factors are greater than 1, then you consider them that as a factor. And if that factor's eigenvalue is less than 1, equal to 1, you do not consider them as a factor. Okay, for example, to find out eigenvalue, there are many different ways, and what this eigenvalues says is actually how much variance can be explained by a factor of all variables, by one factor of all variables. Okay, and that's why it is called one to many relationships are exist between the factor and variable. Okay, so and it shows the variance explained by that particular factor out of the total variance. Okay, so it shows the variance explained by that particular factor. That means the common factor is present in that particular factor or a particular single factor. So that particular factor out of the total variance, how much variance is actually explained by this particular factor. So that's why it is 1 to n relationship is present, that is one factor to all variable. From the communality, we can know how much variance is explained by one factor out of the total variance or by the first factor out of the total variance. First factor means which one is the first in the series if you arrange them in the increasing order, in the decreasing order. And this will help you to decide the number of factors which you can consider for a particular data set. So for example, here these are the number of 6 factors, okay, which you have seen, and for each of the factor these are the eigenvalues. Okay, and how many values are greater than 1, those numbers can be considered as the number of factors. So in this case, in this case 2 is a number of factor for this particular data set. Similarly, for the scree test, if you look at the data set, then where there is a sharp bend or the knee like structure, you can consider that as a value for that particular factor analysis, number of factor for that particular factor analysis, right? But if you plot the eigenvalue, it is not that you are not sure that or you cannot be sure that the graph will looks like this. Sometimes the data set which I have shown you earlier, it will generate something like this. So whether you will consider 2 or whether you will consider 4, that is not clear from this eigenvalue curve or from that scree plot. So what you have to do, you have to choose how many eigenvalues are greater than 1. That can be a possible number for that particular factor analysis. So here number 3 is the 3 where number 3 factors having eigenvalue greater than 1. So consider that factor is equal to 3 for this particular experiment. Okay. So now let's calculate the correlation matrix. I will show you how to do all these things. Okay, it will be very easy. These are the very easy tasks to do from a data set. How to calculate the correlation matrix. Okay, so if you plot this correlation matrix, or if you calculate this correlation matrix, then you can see that scalable has a high correlation with outgoing, hardworking has high correlation with dutiful, and warm-hearted has high correlation with helpful. So like this way you can group them. So your number of factors that is decided in the last slide is 3 can be justified by this means, that outgoing is have a relationship with scalable, hardworking has a relationship with dutiful, and warm-hearted has relationship with helpful. But how to confirm that? And that's where the confirmatory factor analysis comes. So till now we were doing exploratory analysis, and now if we know this, after this, to confirm this we will do confirmatory analysis, right? So this correlation matrix can be used for eigenvalue. So once you have correlation matrix, to confirm it you can go for eigenvalue generation, and then you plot this script in a script plot, and then check whether the number of correlation are equal to number of factors are there or not. Eigenvector can be generated from this correlation matrix. Variance can be generated from this correlation matrix, which is the main important factor for this factor analysis. So this variance can also be calculated separately by using this formula, which is very well known for standard deviation and variance, right? Which is a measure of the spread of numbers in a data set from their means or average. Okay, so what you have to do, say for a particular variable, these are the values. So n values are there for a particular, n are the number of observations, so number of rows, and xi is the value of that particular row, and mu is the mean of that particular row. Okay, and n is the number of population size. Okay, so by this way you can calculate the variance and also the standard deviation. So these are very standard formula. Hopefully you have seen a lot of time throughout this workshop. So if we have the data and if we want to calculate the variance, it is very straightforward by this formula, right? Now by this way, if you calculate the variance of each of these factors and then make a tabular representation and a percentage format, then number one factor says that there is a 31.21% of the total variance can be expressed by factor 1. Factor 2 alone express the 24.71% of the variance, total variance. So if you combine 1 and 2, then 55.72927 percentage of the total variance can be expressed by these two. So if you combine these three, then more than 75% of the total variance can be expressed by these three factors. So that can be justifiable. The number 3 can be a factor for this factor analysis. Okay. Now from there also you can choose how many factors are there, right? Now loading a variable to a factor, how you can relate which variable to which factor. Till now you know that how many factors are ideal for this particular data set, that you can find out by the way I have explained. But which variable to which factor, that is another thing, and here factor loadings come into play. Factor loadings helps you to decide which variables have correlationship with which factor. So how high is the correlation between a factor and a variable? So that means it gives you one-to-one relationship, right? A factor to a variable, which factor to which variable, and component matrix here will help you to decide this. Okay, to understand which variable relates with which factor. For example, factor loading is equal to compute component matrix, and the component matrix of the previous data set or the correlation matrix is like this. And from here you can see, it is clearly seen that factor 1 is correlated with these two variables, factor 2 is correlated with these two variables, factor 3 is correlated with these two variables, right? Hardworking and dutiful, because the values of these variables of these factors are high in these cases. Sometimes you may have similar type of values. Instead of these many differences, almost similar or exactly similar, the situation are different in that cases. Okay, I am not going into that part, but in a simpler scenario where you have a high value of correlationship here in the component matrix, you can relate those variables with those factors. So this variable relates with this factor, this variable with this factor, like this, right? So in optimal case, the values are proportionally distributed between factors and variables. But if not, then we can do another step after this component matrix, and that is called varimax rotation, right? If you do the rotation in the component matrix, what you will get is this, where the main aim is to ensure that per factor certain variables load as high as possible and the other variable load as low as possible by this rotation. And after this rotation, those, if you look at the component matrix, even in these cases the values are still similar. See, in case of dutiful can be under factor 1 or factor 3. But if you look at the varimax, after the applying varimax, the rotated component matrix, if you look at this, then the dutiful have high correlation with factor 3 instead of factor 1. So if you have any confusion after having the component matrix, that which variable correlates with which factor, do another step, apply some rotation and try to get the rotated component matrix, and there the picture will be clear. here what we can say that outgoing and scalable can be grouped, hardworking and dutiful can be grouped, and warm-hearted and helpful can be grouped together. But what will be the name of this factor 1, factor 2 and factor 3? Shall we call them by factor 1, factor 2, factor 3, or we will give a meaningful name? That totally depends on the researcher or the person who is handling that task, right? Like here you will give the name cleanliness or service quality. That totally depends on the person who is working on that. There is no hard and fast rule, right? Because all these three variables can be classified as cleanliness or also can be classified as the food service quality, because staff behavior, cleanliness and waiting time actually relates with the service quality, right? So we have many other terms, personality terms, that can be relate with those those three factors. And for example, outgoing and sociable can be the extraversion, can be correlate with extraversion. Hardworking and dutiful can be relate with agreeableness, and warm-hearted and helpful can be conscientiousness. And we can rename this factor 1, factor 2, factor 3, the extraversion, conscientiousness and agreeableness, or you can give ABC, XYZ, MNO, or whatever you like. Okay, but better to give some meaningful name. Now what next? Next is the communalities. Once the number of factor is determined, the communalities can be calculated. How much variance of the total variable, how much variance of the variables can be explained by all factors. Okay, so that means here m is to n factors are there, relationships are there. How much variance of the variables, then total variance of all the variables can be explained by all the factors, right? So m is to n relationship for all the factors to all the variables are there. And the communality matrix for the same example can be looks like this. So that this has this much of variance can be explained by outgoing at all by the three factors. Like this way, if you can go one by one, it explains the total number of variance explainable by that particular factors or by all those factors. Okay. Now, what was our primary aim? Why we have started understanding factor analysis? Because to reduce the data set, we have 100 rows and 100 columns, and we want to reduce it into fewer columns. But till now we have not seen it. We have only seen that 100 columns can be how these 100 columns can be represented into n columns. But how to generate the n columns? Create variables which cannot be measured. So what are those values of those n latent variables, right? What are the homogeneity or dimensionality of those data of those n variables? That is actually lies in the term called factor score, and that is the last step of this factor analysis. So we have understood factor, how many factor to understand, how many factors to create, which factor to relate with which variable, and now how those variables will be evaluated, the values will be evaluated of those factors. So also called the component score, like component matrix, it is component score. There are estimated scores for each observation on each factor extracted through the factor analysis. By using factor analysis, we can give value. Say for example, in a data set you have 100 columns and 1000 rows. After factor analysis, you decided that the 100 columns can be summarized into 10 columns. And this now the new matrix will have 10 columns and 1000 rows, right? So the new column will have 10 columns and 1000 rows, and what will be the values of those cells? 10 by 1000, that will be decided by this factor score. Factor score represent the relative strength of each observations associated with each factor. So now again you use the previous data, that is 100 by 1000. Factor scores are useful for further analysis such as regression analysis, clustering, where the focus is on the latent factor rather than the observed variable. So after you generate the 10 by 1000 dataset from the 100 by 1000 dataset, now you can do whatever data analysis task you want to do, either regression, clustering, or classification, whatever you want. Not classification, but if you manage the dataset like this, you can also do classification. But in this case of analysis, the old values like the 100 observations will not be used here. Only that new 10 variables or the latent variables will only be used for this analysis. Okay. So there are several methods for this, and factor score are one of them. And perform factor analysis, where perform factor analysis on your dataset to extract the factors that we have done. Extract the factor loading matrix from the factor analysis result that we have already done. Estimate factor score, use the regression method to estimate factor scores for each observation. So from this factor loading, for factor loading matrix, component matrix, combine with the regressed matrix, and then you generate the new data set where you have latent variables and the new data. Okay, so here we have seen that factor analysis can be used for descriptive factor analysis, exploratory factor analysis, confirmatory factor analysis, different ways. Descriptive means to describe those variables with the latent variables, new variables. Exploratory also like how to explore new variables. Confirmatory, like as I have shown you, that once you have understood by the relationship matrix, correlationship matrix, that there are some relationships are present, but how to confirm them, that can be done by using the factor analysis.